Hello, Math 2 Extended. This is Mrs. Bricky, and this video is for Unit 9, Lesson 1. We're going to be talking about quadratic functions in intercept form. A quadratic function is just a function that contains a variable squared. The most basic form of a quadratic function would be y equals x squared. We have graphed and talked about these types of functions before. The shape of a quadratic function is called a parabola. And parabola has a vertex, which would be either the lowest or highest point. And we've talked about that a parabola grows with a 1, 3, 5 pattern. We're not going to be using that as much in this unit, but we will be sketching some parabolas this unit. So you will remember from Unit 7 when we graphed these that the vertex form of a quadratic function sort of shows you the location of the vertex. And we might not have necessarily called this vertex form before, but that name probably makes sense because the numbers that you see in the function tell you the location of the vertex. The x value of the vertex would be with the x inside of a grouping squared. And then the k value, that gives you the y value of the vertex at the end of the function. A tells you about the shape of the function. It's a vertical stretch, so it changes the curvature a little bit depending on what the a value is. So it's a multiplier of our 1, 3, 5 growth pattern. And just remember that if a is negative, the parabola will open downward instead of upward. So here's one just to review that idea of vertex form from Unit 7. So if we have the function y equals negative x plus 5 squared plus 2, our vertex would be at negative 5, 2. So that would be right here. And then the stretch factor is a negative 1. That's right here at the front. We don't see the 1, but it's sort of implied. And so that means that the parabola is going to go in a down 1, down 3, down 5 pattern. So down 1 over 1, and then down 3 over 1, and then down 5 over 1. And that gives us, some points to give us that parabolic shape. The axis of symmetry of this parabola, you'll remember that the axis of symmetry is sort of an imaginary line that cuts that parabola into two equal halves or symmetric halves. So the axis of symmetry of this parabola is x equals negative 5. You should always include the x equals as part of your axis of symmetry equation. And then the extreme value is talking about like that height, that maximum height in this case, which would be 2 or y equals 2. It's less important to me that you write the y equals on the extreme value, but on the axis of symmetry, we're writing the equation of the line of the axis of symmetry, so it really should be x equals negative 5. Okay, so if you wanted to try that one more time, this one has a vertex at 3, negative 8. So it's over here. The growth pattern of this one, the stretch is a stretch factor of 2. So that means we're going to see a 2, 6, 10 pattern. And remember that the stretch multiplies the 1, 3, 5 pattern. It basically doubles that 1, 3, 5. So it's now a 2, 6, 10. So up 2, and then up 6, and then up 10. And then we've got our other symmetric half. Okay, so if we sketch this, I kind of missed the vertex. Okay. You can see that the axis of symmetry, which cuts that parabola right in half, it's at x equals 3. You'll notice that that always matches the x value of the vertex. And in this case, we have a minimum, and the minimum value is negative 8. We have a minimum of negative 8. And you'll notice that that matches the y value of the vertex. So the vertex includes information about both the axis of symmetry and the extreme value. From my sketch, we can see that the y-intercept is happening at 10. And the 2x-intercepts, by the way, on the y-intercept, it's fine if you just list 10. You don't have to write it as a point like that. For the x-intercepts, you can see that they are at 1 and 5. And again, if you list them like this, you don't want parentheses around it. That's a list of 2 x-intercepts. If you want to write them as points, it would be 1, 0, and 5, 0. So no parentheses if you list them the first way, and then, of course, if they're points, you would use parentheses. Okay, so quadratic functions are not always in vertex form. Vertex form is just one of the forms a quadratic can be in. There's 2 other common forms. One is called standard form, and one is called intercept form. Standard form looks like y equals ax squared plus bx plus c. And intercept form is going to look like a times x minus, let's see, p and x minus q. And also, just to reinforce, I'll write the other one, which is vertex form. Vertex form is the one we just looked at. It's y equals a x minus h squared plus k. And you'll notice that a is showing up in each of these equations. Of course, x and y also show up in all of these equations, but the a value is the same for all different forms. So if you have, 1x squared minus 2x minus 3, this Spider-Man up here, the equivalent standard form will also have an a value of 1, and the equivalent vertex form will also have an a value of 1. Now, each of these forms has its advantages and disadvantages. The advantage of vertex form that we've just been working on is it makes the graph very easy to do because it shows you that vertex starting point. But any parabola can be written in any of these 3 forms. And so today we're going to be focusing on intercept form. So first of all, what is the relationship between standard form and intercept form? Well, hopefully looking at the 2 of them, you can see that if you have standard form and you want intercept form, you need to factor that function. And if you have intercept form and you want standard form, wait, I forgot to show you my meme. There you go. From standard form to intercept form, you factor. And sometimes we want to have standard form and we have intercept form. And in that case, if we need to go from intercept form into standard form, it's really just multiplying or distributing, if you want to think of it as distributing, which distributing is just multiplication. So if I have the function f of x equals negative 2 multiplied by x plus 7 multiplied by x minus 3, I can write that in standard form. What we would do here, because we have 3 things being multiplied together, we have a negative 2 and then we have 2 binomials. I like to multiply the 2 binomials together first. If I multiply those 2 binomials together, I'm just multiplying. If I multiply those together, I get x squared plus 4x minus 21, but that is also multiplied by a negative 2, so I need to distribute that negative 2 as well. So standard form of my function is negative 2x squared minus 8x plus 42. So these 2 functions, they are the exact same function. They're the exact same graph if we looked at them. They just are presented in 2 different ways. One is presented in intercept form and the other is presented in standard form. If I have a function g that is written in standard form and I want it in intercept form, I have to think about factoring that function. So in this case, sometimes when we have a coefficient like this 2 in front, sometimes that can be factored out, kind of like the one above had that negative 2 factored out. But in this case, we can't factor out the 2, so we're going to leave it with one of the x's. So let's see, for 15, so we start with that 2x squared, split it up as a 2x times 2x. Now we need to think about that negative 15, so I'm thinking we're going to use a 5 and a 3. If we put the 5 here, it's going to get doubled to be a 10. And so we want the 3 here. To get a negative 7, I want a negative 10x and a positive 3x. So there's my factorization. So again, this function g of x written in intercept form is exactly the same as this function g of x. They are just being presented in two different forms. So sometimes the reason that we want to go back and forth between two different forms is that different forms reveal different things to us. And sometimes we want to go between two different forms because our stinking math teacher asks us to go between two different forms. So anyway, so you do need to be pretty fluent at switching forms. All right, so part B of our lesson, we are now going to start thinking about the relationship between factors and intercept form and the graph. So in class, we did an activity where we looked at several graphs. Because of it being a video, I'm going to go ahead and skip that to here. So intercept form, what that can reveal to us when we have this intercept form of a function, what it reveals to us is where the x-intercepts are, and that is why it is called intercept form. So we have a function f that is a multiplied by x minus p multiplied by x minus q. The p and the q are going to be our x-intercepts. Now, just like with vertex form, and when we have that x minus h, the p and the q's signs will change between the factors and the x-intercepts. So watch out for that. We'll do some examples so I can show you. And also the a at the front here, it's the same as the a in standard form, and it's the same as the a in vertex form. That a will tell you about the stretch of the parabola. So if that a is negative, you know that the parabola opens downward. The vertex, something to note, we'll talk about it more formally in a second, but the vertex is exactly halfway. These things are symmetric. So if P and Q are the x-intercepts, that axis of symmetry is exactly halfway between them, and that's also going to be the x value of the vertex. Let's see. Here we go. So we want to start with this intercept form and sketch the graph. So we see that we have a factor of x minus 3, and that means we're going to have an x-intercept at 3, positive 3 here. And we have what we can see is a factor of x minus 7, and that means we're going to have an x-intercept at positive 7. So we have two x-intercepts for our parabola. The negative here does tell me that my parabola's shape is going to open downward. That's what that minus right there tells me, that it's going to be reflected. And so we need to figure out where the vertex of this is. Well, remember that the vertex is going to be exactly halfway between those two x-intercepts. So if I have an x-intercept at 3 and an x-intercept at 7, my axis of symmetry is going to be exactly halfway in between there. So our vertex is going to be at 5, at the x value 5. And you might not know where to put that vertex. Well, anytime we have a function and we have an x value, we can always sub in to get our y value. So if I'm wondering about the y value of the vertex, I'm going to just figure out what I get when I sub 5 into my function. Sometimes people think it's weird to sub into intercept form, but I actually like it because usually it's pretty easy to mentally calculate. So I have a negative, 5 minus 3 is 2, 5 minus 7 is negative 2, so I have a negative 2 times negative 2, so that is a positive 4. That's going to be the vertex's y value. So my vertex is here at 5, 4. And if you start thinking about the pattern, the 1, 3, 5 pattern, you can see that that's happening here. Down 1, over 1, down 3. And so another point I would have would be here. And I could kind of sketch out a couple of points to get a nice shape on my parabola. Now, most of our parabolas that we sketched this unit, we're not going to have a grid on, so this is probably one of the last grids we'll use. So my next question on my list over there is the y-intercept, and hopefully you're thinking to yourself, I don't know where this is going to cross. I purposefully have a graph here where you can't see the y-intercept. That doesn't mean it doesn't exist, and that doesn't mean we can't find it just because it's not showing up on our grid. It eventually is going to cross this y-axis if I extend it down. We just need to figure out where that happens. So if you think about the y-intercept, the x value of the y-intercept is always 0. So I can use exactly the same idea that I just used with the vertex. I know that x value is 0, so I just need to calculate the y value by subbing in 0 for x. So we have negative quantity 0 minus 3, 0 minus 7, and we need to multiply that all together. And again, I love intercept form for how easy it is to do mental calculations. So this is, it looks like a negative 21. Now that makes sense on my graph. It's not really to scale exactly where I was drawing this pink, but we can tell by looking at the shape of this graph that we should be getting a negative number that's pretty low. So negative 21 makes a lot of sense. Just quick review of range. Range is bottoms up. So for this graph, our range would be from negative infinity up to a maximum height of 4. Bracket on the 4 because that is the vertex. Okay, let's try to find some different items for this graph. You do kind of already have a sketch of the graph, but you'll notice that the y-axis is not labeled at all. Our function is negative x minus 2, x plus 5. So we can see that those factors do correspond to our x-intercepts. This first factor gives me an x-intercept of 2, and this second factor gives me an x-intercept of negative 5. So that's the strength of intercept form. It tells you where those x-intercepts are. You'll notice the parabola is opening downward, and that is because of this negative right here. That negative means I know I'm going to have a downward opening parabola. Okay, so I want to find the axis of symmetry. I want to find the vertex. Well, remember the parabolas are symmetric, so the vertex is going to be exactly halfway in between these two x-intercepts that we just marked. And so on our last example, it was really easy to just see that the halfway point was at 5. But this one is not as easy to see the halfway point. And in fact, the halfway point is not even at an integer value. So if you're looking for the axis of symmetry in vertex or in intercept from intercept form, you can always think of that axis of symmetry as the average of the two x-intercepts. So in this case, if I think about the average of those two x-intercepts, 2 plus negative 5 divided by 2 is negative 3/2. Now, I'm going to stick with fractions here. If you prefer to do decimals, that's okay. When they're terminating decimals, it's fine. You could write negative 1.5. It starts to get a little bit more awkward if your decimals are repeating, like negative 1.66666 or something. So like if you have a repeating decimal, I encourage you to use fraction form. But if you just really want to use a decimal form, you can. All right, so we know the vertex is happening at negative 3/2, which is negative 1.5, which makes sense with our picture. You can kind of see that is definitely what's that line of symmetry. So now we need to find the y value of the vertex, and we're going to find it the same way we've been finding it, and that is we're going to substitute in. I'm going to do it down here at the bottom. F of negative 3/2. Now this one will be not exactly as easy to calculate mentally, so I'm going to go ahead and use my calculator. just to save time, which is the main purpose of a calculator. And let's see, so that would give us 49/4. I'm going to go ahead and write it again in that fraction form. But if you were wondering about the decimal, that's 12.25. So on my graph over here, I'm going to write it in that decimal form. 12.25 is the, oh, I'm sorry, that's not, I put it in the wrong spot. That would be, whoops. That would be the height right here of the vertex. So that vertex point right here is -3/2, 49/4. Okay, so we've got our vertex, and that vertex also tells us the extreme value. That extreme value, that highest value is 49/4, and that is a maximum. Okay, the y-intercept is the last thing we need to calculate. That's right here. You can see that it's a little bit below the 12.25. So again, that happens, y-intercept happens when x is 0. So we can sub in 0 to calculate that. And that gives us, this one is pretty easy to mentally calculate. It gives us, oh, whoops, sorry. It gives us 10, which makes sense because we knew that it was going to be a little bit below the 12.25. Okay, all right, so that one's done. All right, so now we're going to do an example where we actually have standard form, and we don't know how to graph from standard form. I haven't taught you that yet. I'm going to teach you in another lesson, but for now, you don't know how to graph from standard form. We have practiced graphing from vertex form, and we have practiced today graphing from intercept form, but you don't know standard form yet. So we are going to go from standard form into intercept form, and from intercept form we will graph. So we need a factorization of this function. And so we get f of x equals, our leading term is x squared, so we'll throw those x's in there. Our ending number, our constant, is -21. So let's see, we're going to use 7 and 3. With a middle term of -4, we want the 7 negative and the 3 positive. So that intercept form tells us our x-intercepts are at -3 and +7. So let's mark those, -3, +7. Okay, our axis of symmetry and our vertex are located exactly halfway between those. If you have a hard time seeing what that is, again, you can formally average the two. If we add them together and divide by 2, that gives us the average. That's 4 divided by 2, so that's 2. So our axis of symmetry is at x equals 2. And that is the x value of the vertex. Now this parabola, if you think about that, leading coefficient is 1, so we know that this parabola opens upward, so we should be expecting to have a negative y value for our vertex so that it can open, upward through those x-intercepts. And in fact, I'm going to sketch that. I'm going to just put my vertex right here. I don't have a scale on my y-axis, so it doesn't really matter where I put that vertex because I'm going to label it in a second. So I've got my beautiful parabola with its vertex right on the axis of symmetry. To get the y value of that vertex, we're going to sub 2 into our function, f of 2, and it's really your choice. You can sub it into standard form function. You can sub it into the intercept form. I personally love subbing into intercept form because I can just do the mental calculation very easily. Whoops, that's a 7. 2 plus 3 is 5. 2 minus 7 is -5. When I multiply those two together, I get -25. So that is the value of my vertex. That's a negative 25 on my y-axis. Okay, so the extreme value is that we have a minimum of negative 25. All right, the last thing I want to label is my y-intercept. I can see that it's a negative number based on my sketch. I can see that it's a negative number between 0 and negative 25. So let's see if we can calculate it. The y-intercept happens when x is equal to 0. So f of 0 is 0 plus 3 times 0 minus 7. That's a negative 21. And that makes great sense with the rest of that sketch. Okay, so we have, I think, just one final example, and that is that we are going to kind of do the reverse of that. If I show you a picture of the graph, can you write it in both intercept and standard form? Now, this graph, you can see the vertex is not at a nice point, so we're not going to write this one in vertex form, but we could write in vertex form once we have the vertex. So for example, on this one, I could write the vertex form of the function because I know the vertex now. So it'd be easy to do. But for this example, we are just going to focus on intercept form and standard form. So for intercept form, y equals the a value here, not super clear, but it does look like it might just be up 1, up 3, up 5. It's just not lined up very well on the grid. So what we're going to do is just check our y-intercept on our function in a minute to make sure that it matches the negative 10 that we see right here. Okay, so in intercept form, we're going to use the x-intercepts. So I can see that the intercepts are negative 2 and 5. So that means my function has a factor of x plus 2 and a factor of x minus 5. And I suspect that that is the correct intercept form. I think my a value here is just 1, but you can just check because if you sub in 0, you get 2 multiplied by negative 5, you get 0, negative 10, and that matches the y-intercept. So that's great. Now, to get standard form, I do not look at something on the graph. To get standard form, I write down intercept form or I write down vertex form and I multiply it out. So to get standard form, I'm going to multiply this function in intercept form together. So that gives me y equals x squared. I have a negative 5x and a positive 2x. So that's going to be a middle term of negative 3x, and then my constant is negative 10. So this would be standard form of my function. Again, you do not get standard form by looking at something on the graph. You get standard form from multiplying out intercept form. All right, so that is it. You have an assignment in your packet. If you need any help with anything, please let me know. Thanks so much.